Hello and welcome to the 101 Earth Observation Virtual Lecture Series. This series is delivered by the Satellite Applications Catapult in partnership with WILDLABS. This lecture is about data access and processing. We will see this in two different aspects: public data access and processing platform and partially public. So I have shown in previous video that there are different Sentinel missions. How do we actually get this data? The first platform where we can get data, it's called the Copernicus Open Access Hub, or CHUB, and the website is over there. Landsat data, on the other side, can be downloaded directly through the USGS platform, which is called Earth Explorer. So those platforms, they usually require user registration, but then data can be really easily downloaded. And there is a geographical, overview over there where you usually select the area of interest, the time as well, where we want data capture, and then we simply download data. This specific platform has several other data associated, not only Landsat, as we see in the right. SAR data, Sentinel-1 data can be downloaded as well through the Alaska Satellite Facility, ASF. The platform is here. This is useful not only to download data, but to get also some additional products derived with this data and some tools. Copernicus Global Land Service, so this provides free open access data, and it provides with different type of products which describe the state and evolution of the vegetation, water cycle, and so on. So there are different products associated here. Again, website is marked in the slide. Another platform with different products is called Thematic Exploitation Platform, TEP. This is linked to several products from the emergency side, such as we see in this example, for example, a flooding in Germany, to more earth science product and so on. Another platform is called Earth System Data Lab, or Earth in a Box, where we get a multiple varied data set of Earth system variables in a sort of a cube, as in this slide. I mentioned in a previous video about ARD, analysis ready data. Let's have a look here a bit more in detail, because some of those platforms, they actually mention specifically analysis ready data. So analysis ready data are biogeophysical measurements on Earth that are comparable through space and time. So they're built usually in data cubes, and every point in the cube corresponds to a specific geographical location consistently. It's not yet standardized as a concept, and scientific group, several groups exist now to define the specification of analysis-ready data, because several processing steps can be performed to get that specific processing. But I think it's important to mention the name so that we are familiar with it. And generally speaking, this is very good when we want to do a large-scale automated analysis through both inter and intra-sensor interoperability. DataCube, which is I mentioned just before, it's where we can store, for example, analysis-ready data. The Open Data Cube, what you see, it's a Python library that supports applications that facilitate working with large volume of raster data. So this is just a set of Python tools to create cubes. If you move into processing, Sentinel Applications Platform, or SNAP, it's a set of open access toolboxes to open, display, and process Earth observation data. So this is quite a comprehensive software which perform lots of processing. So I've shown in previous video, some of the products that we can derive with Earth observation data. This software can be used to derive some of those products. So it's useful to process data. I mentioned also about GIS, which was an important part of the use of Earth observation and geospatial data to create maps and everything around it. One of the most popular open access software is called QGIS, and it's freely available. It's probably worth mentioning that there are several plugins here that are very suited with QGIS that use Earth observation data, and they do specific analysis such as land classification. A plugin is called semi-automatic classification plugin, for example, that does this. There are more recent versions of QGIS than what's in this slide, and several releases are updated. This is quite an updated software, so there are several releases that are given to the public in a very fast and timely way. Google Earth Engine, it's a platform that I mentioned before. This is very useful when we got to get access to Earth observation data and do processing without actually downloading it. So everything is stored into the Google servers, and all the data that I described before, the publicly available data and the products, they're actually stored there. So we can download data, we can process data, and we can see data without downloading. Eventually, we can also download it. But the good thing of this platform is that it can actually allow an easy access to data without the need of downloading it. This is free for research, and the website is over there. It requires registration and requires a Google account. This was around public, data access and processing. Partially public, I think it's worth mentioning the EO browser and Sentinel Playground. Those are very user-friendly instruments to access Sentinel data and related products. There is a commercial offering here, so that's why it's partially public for more advanced features. But generally speaking, basic features can be accessed for free, and we can see, for example, NDVI maps, moisture maps, and so on. Another partially public product is the Earth on AWS. So this is an on-demand cloud computing platform. So we move into cloud computing, and there are several APIs linked to Earth observation data.